Okay, what's up guys? Jacob here with Smetting Performance. If you've been with the channel for a little while, you can probably tell that I really like LS engines. I'm actually not a die-hard Chevy fan. Just as an engine builder, the LS is a really attractive platform. So, to continue with that, the next engine on the channel is going to be a 416 LS, but this one is going to be different. And I'll give you a sneak peek of why. Boom. But we'll talk more about that later. We have a 416 LS stroker coming together. This motor was originally a very quick 13-to-1 stock bottom end heads cam setup. I think it made high 500s to the wheel, but like stock bottom end setups that are pushed to 8,000 RPM, spun a rod bearing. So it came in here to get the workup and get built up and get the treatment. We're going to put all the good parts in it and ensure that never happens again. So starting with the foundation of this build, we have our Smetting 4340 forged steel super badass crankshaft. This is a 4-inch stroke, which is going to give us our 416 cubic inch. On top of that, we have our Smetting H-beam power adder connecting rods with ARP 2000 rod bolts. These rod bolts are super strong and will not let this rod distort and pinch at really high RPM, so it doesn't spin another rod bearing like the old setup did with the stock rods. We also are running a King XP rod bearing. I'm going to run about 2.1 thousandth on the rods clearance and about 2.5 on the mains. You can see I have the main coated bearings. We are also running a Total Seal 0.9, 0.9, 2.0 ring pack, which I have over there. I'll get those in a little bit. And then to top it off, we have a 14-to-1 compression custom JE piston with lateral gas ports. So this thing is just packed full of features. It also has, I think, 200 or 220. It has really thick, super badass wrist pins in case he ever wants to put a little nitrous to the motor. We're going to build it to handle 1,000 horsepower easily. I anticipate that his new combination will make over 700 NA, and that he can easily hit it with a 300 shot. So a really quick thing. Whenever these engines come in for a rebuild, especially when a motor has damaged itself or spun a bearing, there is trash, aluminum, and debris all through the motor. So to ensure that you get it completely clean, we have to knock out the cam bearings. Just normal deal. Motor's coming for a refresh, let's put all new bearings in it. An iron block, like this big block Chevy, is extremely easy to put new cam bearings into. The iron itself is extremely rigid and strong, and it's an aluminum bearing with a steel outer shell. But anyways, that bearing fits nicely into the block, and realistically, only 1 out of 100 will you ever have a bearing go in a little bit crooked. However, these aluminum LS blocks, I'm going to be honest, and you ask any engine builder, they are tricky. They are really difficult to get the cam bearings right on, especially when you're doing an aftermarket bearing. They have a lot of press fit because LS engines typically have cam bearing issues. At least the early ones did. Gen 4 motors like this, not so much, but Gen 3s have some problems. But I just got a new super badass tool, because normally when you do a cam bearing like on these iron blocks, they're so easy that we have this long rod. It has a cone head, or I'm sorry, it has an expanding head. This head will expand to fit the bearing, and then this cone lines up the whole assembly with the front thing here, and then you just hammer it in. And on an iron block, it works great, super cool. On the aluminum blocks though, it's doable. I've done it several times, it works. It just takes a little extra effort, but I just got a new super cool tool that I want to bust out and show y'all. Okay, so here's the cam bearing that I'm going to be installing. This is a coated Durbond bearing. But here's the new tool. So it's still a solid metal rod with a cone to align it, but it's a metal cone that is extremely tight tolerance on this shaft instead of the plastic one. And then instead of pushing the cam bearing in, it actually has this little puck. Cam bearing fits over the puck. This goes on right here, like so. And then we're actually going to pull the cam bearing with this big threaded rod right here. So I'm really excited to give this thing a shot and see how it goes. So I don't think I'll be able to show you all the other side, but basically I have the bearing chucked up and I'm going to spin this and it's going to pull the bearing into the block. That way it forces everything to be perfectly lined up. Oh wow. Tell you what, that is super easy. Holy crap. Wow. That beats the hell out of hammering these freaking things. Take off the lock. Slide all this out. And then I can check my alignment. Wow. That is money well spent. BHJ makes that tool. If you're an engine builder and want to get one, that is a freaking lifesaver. Oh yeah. That'll do. Alright, let's do the others. That was freaking awesome. Stick this back in. Let's back this off a little bit. Give us a little room. And get the next bearing. Again, we have our puck here. Bearing goes on the puck. Install all of that onto this main shaft. And then it's got this key that basically locks the shaft from turning. Okay, I just grabbed an LS cam off the shelf just to check it. And yeah, I mean, it is very smooth and straight for being coated bearings. So I'm pretty happy with that tool. It worked out really nicely. So next step, this motor is getting main studs. So we're gonna get those epoxied into the block. And this girl will be ready to keep moving forward. Okay, whenever I install main studs and blocks, I actually Loctite them into place. I use this Loctite, which is green. It's very similar to red, but a little more heat temperature resistance. Anyways, put Loctite on the threads, run the studs all the way down, and then I back them off half a turn. On aluminum blocks, what can happen, or it's not just aluminum, but on iron too, if you run your stud all the way down and it bottoms out in the block, and then you go to torque your nut on top, most of the time the nut will torque on the stud and the stud won't move, but sometimes the stud will try to go down and it'll crack the block. So to be safe, put a little Loctite on them, I back them off half a turn, and as I'm checking the main bearing clearances, they'll set up. If they move a little bit while I'm checking before they've cured, they're only going to move a quarter turn and we're still good. But long story short, main studs are in. I can continue on and check bearing clearance. Let's see what the mains are. Okay, we are a little loose compared to where I would like to be. So right now I'm getting about 3 thou on some of them. That's a little looser. That's a little bit too loose. So what we're going to do, right now I have a set of standards in the block. I'm going to cut it, and I'm going to write a standard in the block and a 1 under in the cap. And that should bring us down to the 2.5 clearance zone. Okay, off camera, I swapped out to a half set of 1 unders and half set of standards. And now we're into the 2.5 zone, right where I want to be. The bearing clearance exactly where I want it. We are ready to install the crankshaft. I'm going to do a thin coat of some Clevite assembly lube. I think they call it like Clevite bearing guard, I think is what it's called. And then we will get our beautiful 4-inch stroke Smeding crankshaft. Drop that bad boy in there. And then we'll pop the upper main caps back on. I have already clearanced this block for the extra stroke. So we are ready to assemble. The only other thing we need to do is gap the piston rings. And because this may potentially become a nitrous motor someday, I'm going to gap those accordingly. With this bore size, we'll probably run like a 26 thou gap, maybe 27, and that'll give him plenty of room to get a little spicy with the nitrous. I'm sorry guys, it is an oven in my shop right now. And I can't turn the fans on because whenever the fans are on, that's all you guys would hear. It's just the tornado of air. But it's alright. We will endure. I'm going to put the side bolts in last. I put RTV underneath the heads of them because we are on team no oil leaks. And just in case I didn't clearance the block enough and I have to take everything back apart, I'd rather just have to clean up oil than also have to dig RTV out of those holes. So we're going to leave it there for now and move on to piston rings. Okay, currently the rings are all 6 to 7 thousandths, and my final spec is 27. So I'm going to whack them all about 20 thou, and then recheck. Okay, fast forward a little bit. All the rings in this motor are now gapped now. Here's a shot of that second ring. This is a ductile iron Napier second, and Napier stands for this little hook right here that you can see. I pretty much run these in every engine nowadays. They allow you to run a much lower tension oil ring, but not have the oil consumption issues that are normally associated with a low tension oil because these physically scrape oil off the wall. So after I finish gapping all of these, I come back with a little diamond file and deburr all the little edges where I've gapped it. You can kind of see a shiny mark there. That way they don't hang up on the pistons. Speaking of the pistons, here they are. 14cc power adder piston package, again with the lateral gas ports on that top ring. So as there's any compression or expanding gas inside of this engine while it's running, it's going to put extra pressure on that top ring, really seal up this man. So I'm going to put the rings on the pistons, and this baby is ready to assemble. I almost forgot. So normally with a stroker LS, because the piston gets so short, the wrist pin groove penetrates through the oil ring right there. See that? Whereas because we're running such a thin ring set, we can move the rings closer together and that won't penetrate the oil groove, again cutting down on oil consumption. Another really cool thing about these Total Seal AP rings, I really like them. All right, bank one is done. Those are freaking cool. Let's do the other side. These rod bolts, they torque to 30 pounds on the first pass, and then they go to 60 degrees on the second to get the correct stretch. So you need a torque wrench like this that can measure literally in degrees. My other favorite thing about this wrench is it counts for you. See there it says 16. That way if someone interrupts me or a phone call comes in, it knows right where I left off. And last but not least, the final piece of the puzzle for this little unit. Tell you guys what, feels good to have this dude done. Because now we can all admire how freaking cool dome pistons are. Nope, hold on, I lied. There we go. Those are the coolest freaking things. Don't get me wrong, I really like turbo engines, but nothing is as cool as a naturally aspirated engine. Just all the different things that you can do to make one more horsepower is really kind of cool and exciting to me as an engine builder. But there you go, 14-to-1 416 LS3. I don't know if he already has a cam for this combo or has decided on one yet, but depending on what top end he ends up going with, this has the potential of being probably one of the fastest 416s out on the street. It's going in a super lightweight 5th gen Camaro. I think he's trying to get it down there. I'm not gonna say how light, but it's the old hacksaw mod. Anyways, that's just a joke to the owner. Alright guys, thank you so much for watching. Really appreciate it. I have sweated my ass off here in Texas and I cannot wait to go home and take a cold shower. Keep this in your dreams tonight. This thing is cool. I'm excited to see what happens to it.